Hello and welcome to the lecture. So, in the previous lecture, we were talking about molecular orbital theory and we were discussing the formation of molecules using molecular orbitals, and we were calculating the bond order, whether the molecule it is paramagnetic or diamagnetic. Now, we will further proceed in this lecture. So, we were talking in the last lecture, we have talked about formation of nitrogen molecule. Now, here we will talk another molecule, that is why we will look about what is the bond order in case of N2 positive, N2 positive. Now, in case of N2 positive, we have one of the electron from molecular orbital that is removed. So if I draw the molecular orbital of N2, it will be like this. So here we have N2. Now we will have sigma molecular orbital, we will have pi molecular orbitals. Similarly, we will have 2 pi star antibonding molecular orbitals, and we will have 1 sigma star antibonding molecular orbital. Now we have here 1, 2 and 3 electrons, and one of the electron it is removed. It means that we have only 2 electrons. So we have to fill 5 electrons. Now we will fill the 5 electrons first in bonding molecular orbitals. Now here will be 2 electrons. So here we have 1 electron, 2 electron and 3 electron. So this is the filling of electrons in bonding molecular orbital. Now if I calculate the bond order for N2 positive, so it will be 1 divided by 2 number of electrons in bonding molecular orbital, that is 5, and number of electrons in antibonding, that is 0. So the total will be 5 divided by 2, so it will be 2.5. Now the bond order for N2 positive it is 2.5. Now here we have one of the electron, here we have one unpaired electron. It means that we have unpaired electron. So as we know that unpaired electron, so this substance it will be paramagnetic in nature. Paramagnetic in nature. Similarly, if I look here, if I look formation of N2 negative, or we can say that N2, here we have discussed N2 positive, here we will discuss N2 positive. It means that 2 electrons they have been removed, so there will be 4 electrons. There will be 4 electrons, and they will be filled in. 2 of the electrons they will be filled in sigma bonding molecular orbital, and 2 they will be filled in pi bonding orbital. Now it means that the 4 electrons they all will be filled in bonding molecular orbital. Now it means if I have to calculate the bond order of N2 plus 2 species, so it will be equal to 1 divided by 2 number of electrons in bonding molecular orbital, that is 4, minus number of electrons in antibonding, that is 0. So it will be 4 divided by 2. So there the bond order for N2 plus 2 it is 2. Now since the 2 electrons, if I fill if there are, this is pi bonding molecular orbital, so the 2 electrons that are present in pi bonding they will be like this. So it means that here the 2 electrons they are unpaired. So the electrons in case of N2 plus 2 they are unpaired. This will be paramagnetic in nature. It will be paramagnetic in nature. So we can conclude that if we have N2, it possesses bond order equal to 3, and plus it is having bond order of 2.5, and N2 plus 2, it is having a bond order of 2. Now, as we have a concept that bond order, it is directly proportional to stability. It is directly proportional to stability. So if I have to arrange these species in increasing order of energy, we will have N2, or increasing order of stability. N2, it will be more stable as compared to N2 plus N2 compared to N2 plus 2. Why? Because this has N2, it is having bond order of 3.5, and N2 plus 2, it possesses bond order of 2. So this is the order of stability in case of nitrogen species. So N2, it is having bond order of 3, it means that it is having highest stability. Similarly, as we have seen in this case, we have carbon 2. In the previous lecture, we have seen how formation of carbon takes place. Similarly, if we have here carbon, it is having carbon plus 2. So carbon plus 2, it means it will have 3 electrons. So 2 of the electrons, they will be present in sigma molecular or sigma bonding molecular orbital, and 1 of the electron that will be present in pi bonding molecular orbital. Now if I have to calculate the bond order of this species, so it will be equal to 1 divided by 2 number of electrons in bonding minus number of electrons in antibonding, that is 0. So it will be 3 divided by 2, so it will be equal to 1.4. Similarly, if there is this species C2 negative, then it will have number of electrons, it will be equal to 6 electrons. So it means that 2 electrons, they will be filled in sigma bonding molecular orbital, and 4 electrons,